Hello. Under quadrilaterals, we will be taking up sufficient conditions for a quadrilateral to be a parallelogram. Under that, we will be taking a converse theorem. A quadrilateral is a parallelogram if its opposite sides are equal. We write the question first. This is a converse theorem. A quadrilateral is a parallelogram if its opposite sides are equal. Let us draw a parallelogram because we have to prove this quadrilateral to be a parallelogram at the end. Let me name them as well. Hope it's look like one. I name it as A, B, C and D. We have to prove ABCD parallelogram. It says opposite sides are equal. It is given that its sides are equal. So once I start writing, I'll be given part will be AB is equal to CD and BC is equal to AD. That is given in quadrilateral ABCD. I can write. I'm still using this short form for quadrilateral for saving some time. Herein I will be writing to prove ABCD is a parallelogram. What do we need to prove ABCD to be a parallelogram? We need to prove opposite sides parallel. So we prove AB parallel to CD and AD parallel to BC. To do so, let me join the diagonal AC, dividing the quadrilateral into two triangles. So once I start writing the proof here, we take these two triangles as because we have to prove. How do we prove the triangles? The lines to be parallel? If we either take up the two triangles, thereby equating these two angles ACB and BAC, they will make alternate angles, thereby making CD and AB parallel. Now to do so, I'm just trying to take your reverse. Why are we trying to prove the congruency of these two triangles? By proving the congruency of these two triangles, we'll be able to prove the equality of this angle with this angle, okay, thereby making them a pair of alternate angles. So I write in triangle ACB and triangle CAD. We know that, so it will be AB equal to CD, that is given already to us. CB is equal to AD, that's also given, and this line which is diagonal I have drawn is equal, so I can write AC is equal to CA, that's the common side, thereby proving the congruency of ACB with triangle CAD by SSS criterion. Once we do so, obviously by CPCT we can prove angle it will be ACD, the angle which I had marked. Now here if I am writing angle ACB, it will be like CAB, the marked angle, equal to angle ACD. This is by CPCT. You know what about it? It's a corresponding part of congruent triangles. Thereby, these two are alternate interior angles, thereby making AB parallel to DC. The same process can be followed when we take the diagonal BD. We then prove with the same SSS congruency the congruency of the triangle this and this. That becomes angle ACD with triangle CBA to be congruent. So therefore, making angle CAD congruent to BCA, and therefore AD becomes parallel to BC, as we did this for the previous one. Here opposite sides are parallel, thereby making ABCD a parallelogram. Let's move on with another question. These are all converse theorem which we are taking, which we actually will be proving the sufficient or enough of conditions for making the quadrilateral a parallelogram. I write, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Again, I draw a quadrilateral as because that's supposed to be proved as parallelogram. It says the diagonal of a quadrilateral bisect each other. That means A, if I name this as OAO is equal to OC, BO is equal to OD. We have to prove it to be parallelogram, and to do so we again have to prove CD parallel to AB and AD parallel to BC. You write the same way as we did the previous question. We write AO given to be equal to OC, okay, and then we write BO equals to OD. We have to prove ABCD is a parallelogram. Now to do so, obviously we have to prove the opposite sides parallel. So we start the proof. Let's take these two angles, triangles. If we prove the congruency of these two triangles, AOD and COB, that will prove the congruency, and once we prove the congruency, we can say that OAD angle is equal to OCB, thereby making these two alternate again, and thereby proving AD and BC to be parallelograms. So to do so, we know that OD is equal to OB. As well, we know that OA is equal to OC, and these two are vertically opposite angle. So angle AOD can be equated to angle COB. Therefore, triangle AOD is congruent to triangle COB by S SAS congruency. Now once we prove the congruency of these two triangles, the angles I had marked previously, and that is angle OAD then becomes equal to angle OCB by CPCT, thereby making AD, as because these two are alternate interior, thereby making AD parallel to BC. We can similarly take the triangle and we take the triangles COD and prove the congruency with AOB, and by CPCT again we can prove this equality of these two angles, thereby proving BA parallel to DC. Now as because opposite sides, similarly you can prove this by SAS congruency again. BA becomes parallel to DC, thereby making these two opposite sides parallel, thereby making ABCD is a parallelogram. Hope you followed it well. Let's move on with some more proofs. The next question which I will be taking is, I write the question here first. Show that if the diagonals of a quadrilateral bisect each other at right angles, then it is a rhombus. We have to prove a quadrilateral to be rhombus. Let me draw one rhombus. That means we have to draw one with all four sides equal. I hope it looks like one. I take this as A, B, C, D. So let A, B, C, D is a quadrilateral, and it says the diagonals of this quadrilateral, if I draw, they bisect each other at right angle. That means this is O. What does this refer to? It's given to us that OA is equal to OC. This is equal to this. And then OB is equal to OD. Angle AOB, angle BOC, angle COD and DOA, they are all equals 90 degree. They are all equal to 90 degrees. We simply have to prove AB equals BC equals CD equals DA. Now let's take these two triangles. Once we prove the congruency of these two triangles, then AB will be equal to BC by CPCT. We write to prove AB equals BC equals CD equals DA, thereby making ABCD is a rhombus. So the proof: take the congruency of AOB and BOC triangle. In AOB and BOC, OA is equal to OC, OB is common, and angle AOB is equal to angle COB is equal to, given to be 90 degree, thereby proving SAS criteria used to prove the congruency of these two triangles. Once these two triangles are proved congruent, by CPCT we can say AB is equal to CB. You can write here CPCT. Now, as because this is a quadrilateral whose diagonals bisect each other, that is enough to prove ABCD to be a parallelogram. So, we can write ABCD is a parallelogram as well, as diagonals bisect each other only in parallelogram. Diagonals bisect each other at right angles. Where ABCD is a parallelogram, and also we have proved AB is equal to CB. As because that was parallel, that means what? AB was equal to already CD, and now we have proved AB is also equal to BC, thereby making BC also equal CD. On the other hand, this was 1, this is 2. One more thing we can say is BC is also equal to AD from again the parallelogram. So, thereby making AB equals BC equals CD equals AD, or you can write DA, thereby proving all the four sides equal and making this quadrilateral ABCD to be a rhombus. Hope you followed. See you soon with more on the theorems. Thank you.